root bridge. A root bridge. Now, there are three basic rules for spanning tree. Number one, there will be one root bridge per network. Number two, there can be one root port per non-root bridge. Number three, there's one designated port per segment. Let's take a look at this rule. In this particular example, switch 1 is being chosen as the root bridge. How does that root bridge election take place? What we use is something called Bridge Protocol Data Units. It's commonly referred to as BPDUs. Bridge Protocol Data Units, and I'm serious, we really call them BPDUs. Bridge Protocol Data Units are frames that are sent out every 2 seconds. They're sent out every 2 seconds by the root bridge. There's initially, all switches, when they come online, think that they're the root bridge, and so they begin sending out these Bridge Protocol Data Units, these BPDUs. These are sent out every 2 seconds by the root bridge once the election takes place. Now, how does that election take place? The election takes place by using something called the root bridge ID, or should I say the bridge ID. The bridge ID. The bridge ID is made up of two parts. One, the bridge priority plus the MAC address. The default priority for any switch is going to be 32,768. This is 8,000 in hex. This is a hexadecimal number of 8,000. That's the default priority on any of these switches. So if the default is left in place, if the default priority is left in place, it will be the device with the lowest MAC address. So the election of the root bridge goes to the device with the lowest bridge ID. The bridge ID is made up of two parts: the bridge priority, default 32,768, plus the MAC address. If the priorities are all the same, the lowest MAC address will be selected as the root bridge. In this particular example, this switch, I'm just going to say, has the lowest MAC address. So therefore, this switch is elected as the root bridge. So that's our first rule of spanning tree. There's one root bridge per network. The second rule of spanning tree is there can be one root port per non-root bridge. Let's take a look at that. In this example, we said this switch 1 right here is the root bridge. Switch 2 then is going to be a non-root bridge. Any switch in the network that is not the root bridge is, of course, the non-root bridge. The rule says there can be one root port per non-root bridge. What is the root port? The root port is the port on the switch that is going to the root bridge. Now, I'm splitting hairs a little bit, but I'm saying that this is to the root bridge. This is the port going to the root bridge. From this switch, my connection to the root bridge is my root port. Keep in mind the terminology that we're following here. We're using the term spanning tree. So basically what we've got is we've got a tree. There's a root, and then there's fruit. Okay? Any fruit on a tree is connected to a branch, and that fruit and that branch only has one connection or one path back to the root. And so by that same token, here's the root bridge. This is the root of spanning tree, the reference point by which all of the other switches will govern themselves. All of the non-root bridges, or in this example here, our analogy here, all of the fruit will have one connection back to the root. So on the non-root bridge, there is one root port. So that means any other ports Any redundant paths to the root bridge would be blocked. So that's our second rule. One root port per non-root bridge. The third rule for spanning tree is that there can be one designated port per segment. Let's take a look at that. Note here we have two segments. Root bridge, non-root bridge. For each one of these segments, there will be one designated port. We said that a root port is on a non-root switch or non-root bridge, and that's going to be the port that goes to the root bridge. A designated port it's sort of like the official word from the root bridge. For this segment, for segment 1, the communication from this root bridge is going to come by way of this port right here. The communication on segment 2 will come by way of this port right here on switch 1. Let's take this a step further and let's add another switch, switch 3. And switch 3 has a connection over here. And here's switch 4.